Hello everyone and welcome back to RNM-LABGH. Today I'm presenting a very interesting project that has multiple uses, even at a professional level, 2-axis stabilization using Arduino. Despite its usefulness, the project is not complicated at all. The connections are simple and, as always, I have prepared an easy diagram to guide you step by step. Required materials. To complete this project, we will use the following components. Our trusty Arduino Uno and Gimbal wires, 2 mini servo motors to control the pitch and roll axis, 1 GE-521 board or MPU-6050, the heart of our inclination detection system, 1 prototype Shield V5 board optional, but recommended to simplify and easily access multiple ground GND and Power 5V connections. These are all the materials we will use for our project. At the end of the component assembly, I will show you how I built the mechanical structure so we can test and put our stabilization system into action. Here we are. Now I'm going to show you how I've built the mechanical structure for our stabilization project. As you know, we always try to use recycled materials or materials that are easily available and low cost. Today we will be using scraps of VO board or perforated boards as phenolic or fiberglass boards used to build our finished and functional electronic projects. These perf boards, while commonly used for soldered circuits, are also extremely useful for creating lightweight and robust structures. Since I don't throw anything away, I saved the scraps from my past projects, and as you can see, they are very useful today. I focused on this material because, in the future, we can reuse it often for our final projects. I hope these insights I'm providing can be useful and interesting for all of you. I am truly happy to make my experience available to everyone. Now we move to the computer for the final phase, uploading the code to Arduino. First, connect the USB cable between the Arduino and the computer. Then, open the Arduino IDE and load the complete code that I have prepared for you. As always, you can find it in the description link, along with the assembly diagram for the components. Before you upload the code, you must ensure that you have installed the necessary libraries, Wire H, Server H, and MPU-6050 token H. You can find the correct names for these libraries inside the code description. Remember to always select the correct board, usually Arduino Uno, and the correct USB port in the Tools menu. Once everything is selected, we upload the code to the Arduino. As soon as the upload is complete, we can move on to visualizing our project in action and observe the real-time stabilization. Now we will see our project working in action. As you can see, it is very reactive and precise in its stabilization. Currently, it is a simple benchtop demonstration project, but this control principle can be used to create truly professional supports. For example, we can design a webcam support that keeps us in the correct position even when we move. The webcam will always maintain its stable 0 point on the defined axis. And this is just one of many uses. With a little imagination, it is possible to develop real professional level projects starting from these basics. Thank you all for watching this video until the end. Your support is fundamental. Subscribe to the channel, leave a like, and click the bell to receive notifications for new content. I also ask you to share the content. It costs you nothing, but for me, it is very important so I can continue to bring you increasingly interesting, valuable, and high-quality projects. What I am doing is a significant amount of work. It takes up a lot of time and energy, and it also involves costs. If you want to help this channel grow, just subscribe, share, and leave a like. Oh, I almost forgot. For any information, please write in the comments or send an email. I always respond to everyone. Thank you very much, and see you in the next video.